Right, the first bit, you've got to do f of x plus pi, so you've got to replace all the x's with x plus pi in the function f of x. So here we go. So there's an x plus pi in there. You've got to replace that x with x plus pi. You get this. This can be multiplied out and then split up. So using the multiplication addition law, if you like, of indices, you get here, that's 1/5. So you get to there, so you can swap those two over. But the crucial thing is what you do with this sine of x plus pi. Well, let's have a little look at this. Here's the sine x curve. Sine of x plus pi is a shift of this curve to the left by pi radians, which is 180 degrees. So it's going to go there. So there's sine of x plus pi. This is sine of x. And you'll see that this one is just the top one flipped upside down, which is just the negative of sine x. So sine of x plus pi can be exchanged for the negative of sine x. That's how you get the minus in the answer. So there's that one. There's that nasty bit, and then you can swap that for minus sine x, and then you just rearrange your answer to get the thing that you're after. There it is, and of course all of that bit there is just f of x as required. Okay, pause. So the second bit, I'm probably going to have to pause and scroll this down in halfway through this because I haven't got very much space. You've got to make a substitution in an integration and show that this integration turns into this integration by making the substitution. And you can see that there's quite a few links with the bit above that we've just done, but I'll sort of ignore that, although I might mention that as we go along. So first of all, let's replace this statement here with the actual f of x in there before we think about trying to integrate. So, or make the substitution, I mean. So there you go. There's your f of x, and you've got to replace or use this u substitution. U is x minus pi, and swap all these x's for pi's. Okay, and you make sure you swap the limits too. So why don't we swap the limits first, because that's the nice easy bit and it's worth a mark. When x is 2 pi, u equals 2 pi minus pi, so that will equal pi. When x is pi, the lower limit for u will be pi minus pi, which is 0, which is kind of what we want. So we've already got a bit of confidence up that everything's going well so far. Alright, so let's just section that off. Alright, so don't get it confused with some more working. I'm going to go over here now onto the right hand side because I've got a bit more space here. So I need to start replacing that x there and that x there with u's, and don't forget I've got to replace that dx for a du. So maybe we'll sort that out first as well. There's my substitution. You should remember you need to differentiate that. Well, x differentiates to 1 and pi being a constant differentiates away to nothing. So this tells you can directly swap dx and du over. Alright, so we're no funny business with the dx. Now then, we've got to replace these x's here with u's, which isn't that difficult. Well, sorry, isn't that obvious perhaps when it's written like it is there, but if we rearrange that substitution, we work out x is u plus pi. So we can swap all the x's up here with u plus pi, which shouldn't be a surprise because we've had x plus pi previously in the question. There's been lots of plus pi going on. So we're now going to pop that in and we're going to change the limits. Alright, so if we stick that in there we get this, and then if we replace that x we get this. So there we go, I've replaced all the x's with u plus pi. Okay, and this now has massive similarities to the previous bit of the question. Alright, you should understand why we've done that previous bit. You can multiply this out and split it up in the same way that you did the previous bit, and the e to the minus a fifth of pi is a constant, so that can come out the front like that. Alright, and that will leave e to the minus a fifth of u. This sine u plus pi, in the same way that we swap sine of x plus pi for minus sine x, you can swap that bit there for minus sine u. Alright, now I've got to be careful because this looks like a subtraction sign and it's not. So let's put a bracket round that so it looks like it's this e times this negative sine u. And this minus, of course, can come out the front. Alright, so let's just quickly do that and cross that off. A little bit naughty. Don't do that in the exam, but I'm running out of space, as you can see. Alright, and then that's pretty much the answer, because this here is just f of u. Alright, which is what they're after. So I've got the right minus thing in the front, and I've got my f of u here, and I've got my correct limit. So it's all done. I have to interpret the result graphically. Now, you might not quite understand what it says in the mark scheme for this. It says in the mark scheme that this area here between 2 pi and pi is this much times the area under f of x between 0 and pi. Now, you might not like it because this is all to do with u's, and it says it's this much times the area underneath f of x between 0 and pi. But this is now directly interchangeable for x. Okay, this is just, you know, a variable. Okay, so this is effectively kind of f of x really, because it's exactly the same function. Alright, we've made the substitution u equals x minus pi, and that's caused this to come out the front. You're effectively left with the same function there. It's got a different variable, but you know, it's going to give you the same area if you were to plot y against u as if you were to plot y against x. You might not fully understand that one, I'm afraid, but that's the way it is. End of video.